Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about Eulers Phi function and reduced residue modulo m. Before we move on to the Eulers Phi function, let's try to understand what is meant by relatively prime or co-prime numbers. If a comma b, when we are going to say that a comma b are relatively prime, if its GCD of a comma b equal to 1, then we say that a and b are relatively prime numbers or co-prime numbers. So now try to understand what is meant by Euler's Phi function. Euler's Phi function phi of m, we call it as Euler's Phi function is also named it as Euler's Taussian function. Phi of m is given as the number of, means the count of positive integers that are less than m and relatively prime to m. That count we call it as a Euler's Phi function. That is what it is going to give you. With example, you will get clarity. Phi of 20, here m is equal to 20. That is equal to 1, 3, 7, 9, 11, 13, 17, 19. All these numbers are relatively prime to 20, that are less than 20. So GCD of 1, 20 is 1, GCD of 3, 20 is 1, GCD of 7, 20 is 1, GCD of 9, 20 is 1. So total how many numbers are there? 8 numbers are there. Our Euler's Phi function is going to give you phi of 20 is equal to 8. So as of now in discrete mathematics, this understanding is enough. The definition of Euler's Phi function is enough. But in cryptography, we are going to discuss, we are going to extend this concept, how we are going to identify the Euler's Phi function, means the value of phi for large numbers. How we are going to do that, these things we are going to discuss in our cryptography. But as of now in discrete mathematics, this definition is enough. This is what we are going to use it in our next classes when we discuss about Euler's theorem. Now coming to the next definition, reduced residue modulo m. This is a bit confusing to understand, but try to understand it properly. Anyhow, at the end we are going to give you the shortcut. You simply follow the shortcut, you are going to get the reduced residue modulo m. So reduced residue modulo m is the set of integers. The set of integers Ri such that this set of integers, you take any one of the integer, it is going to have GCD of Ri comma m is going to be 1. And the definition is not yet completed, the remaining part is there. First try to understand the example, then we are going to cover this definition along with example. Now reduced residue modulo of 6 equal to the set of elements 1, 5. This we call it as reduced residue modulo 6. Means 1 GCD of 6, 1 equal to 1. GCD of 5, 6 equal to 1. But understand it properly. It is a set of elements. GCD of Ri, m is going to be 1. But there are so many numbers which is having a GCD value equal to 1. Suppose, let's take an example, 7. GCD of 7, 6 is equal to 1. But why we have not considered the 7 into the reduced residue modulo set? And similarly, GCD of 11, 6 is equal to 1. We have not considered that. So that point you need to understand the second part of the definition. So it has to maintain that such that GCD of Ri, m is equal to 1 such that if x is relatively prime to m, if you take any number that is relatively prime to m, its congruent modulo m is equivalent to some value in Ri. Understand it properly with the example. Let's take a 7. 7 is GCD of 7, 6 is equal to 1, but 7 modulo 6 which is equal to 1. So congruence modulo m to some Ri. 7 modulo 6 equal to 1. That's why 1, 5r is taken as reduced residue modulo. Similarly, 11, 6. 11 modulo 6 which is 5. If you do that, you are going to get one of the value in this reduced residue modulo. Similarly, 13 GCD of 13 comma 6 is equal to 1, but 13 modulus 6 you are going to get 1. So that's why these two we call it as reduced residue modulo. So if you don't understand what all this, forget about all this. So if you want to identify reduced residue modulo of 6, the numbers that are less than 6, the positive numbers that are less than 6, which is 1, 2, 3, 4, 5. Out of this, select the numbers that are relatively prime to 6. Means GCD of 1 comma 6 is equal to 1, GCD of 5 comma 6 is equal to 1. You select those numbers. Above 6, you consider any number. If you do the reduced residue, means if you do the congruence modulo, it is going to give you one of the value in this reduced residue modulo. Similarly, reduced residue modulo of 10 is equal to 1 comma 3 comma 7 comma 9. GCD of 1 comma 10 is equal to 1. GCD of 3 comma 10 is equal to 1. GCD of 7 comma 10 is equal to 1. But GCD of 11 comma 10 is also 1. So 11 modulus 10 you are going to get 1. GCD of 13 comma 10 is also 1. But 13 modulus 10 you are going to get 3. If you do the congruence modulo with 10, you are going to get one of the value in this reduced residue value. This set we call it as reduced residue modulo M. Hope you understand the definitions of Eulers Phi function and reduced residue modulo. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.